to Two Friends Talking Tanzu. My name is Whitney Lee. I'm a developer advocate at VMware Tanzu and a CNCF ambassador, and I'm here with my friend Oren. Oren, will you introduce yourself, please?
Hey everyone, I'm Owen Penso. I'm the Director of Product Strategy in Tanzu.
Awesome. So today we're going to talk about VMware Tanzu platform build. We're going to talk about the build step. But before we do that, let's talk about what problem build is solving. Like, what was the world like before build existed?
Yeah, well, to do that, we need to talk about the build itself. When we are building an application, compiling code, we are creating
Uh-huh.
a binary to run it, right?
Uh-huh.
And there's different languages, different teams will choose different languages. In the last couple of years, there's a lot more languages that are more common in the organization than we had to. Like in the
Mm-hmm.
past, we had only one or two. Now we have a lot, like five, six that you can use. Each build would look differently for every language.
Mm-hmm.
And each team can decide which language they want to use and how they want to build. Now, in the past, before containers and cloud native, when we compiled the code into a binary and ran that in on an OS, and we could have decided which OS, what are the application
Uh-huh.
dependencies the application needs, and what is the application runtime, what are the surrounding services that will run on the same OS for the application. Now,
Uh-huh.
the digital transformation, like the cloud native era, just changed the way that we address that because now we are creating container images. And container images are basically exactly the same thing. It's not different in the way that we are layering things, but it's
Uh-huh.
all in the same file. It's all in the same image. You can run your application and your application runtime, application dependencies, and OS inside
Mm-hmm.
one file that allows you to then decide the like consistency and the way that you want your organization to work regardless of any language that you're using. So what we try to do with container images is to be more agnostic into where are we running that image. So a
Mm-hmm.
container image can run on any Linux, on any cloud, on-prem, off-prem, can run with orchestration like Kubernetes or not on Docker hosts. So that problem was solved by the container image like component. Now,
Yep.
container images also allows us to do um, other thing, which is get that consistency across different teams and languages. So when you create a container image, you basically, in the most simple way, if you want to create that from a Docker file, and that's still the way that a lot of customers does that, and you
Uh-huh.
just need to state what is the OS that you want to use, what are the dependencies, what are the layers that you want to add, and then, of
Uh-huh.
course, your piece of code into that mix. The
Uh-huh.
problem is that exactly like before, you can still create a lot of different snowflakes because a lot of different teams can create a lot of different ways to create that
Uh-huh.
container image.
Uh-huh.
And that's part of the problem of build. How do you make that container images consistent across your organization? Because when you do that, you can then address security issues and operational issues. When you get consistency, you get that, you know, Goldilocks zone of not managing so many components, but only one single path to production, what we call the golden path to production, a single way to go from code into production, no matter which language you use. Now that's the key, right? No matter which language you use.
So what I'm hearing is basically there's so many variables in modern software. So besides many languages, there are many build strategies for all those languages. There are many different operating systems you might use, many supporting services, so many dependencies, so many destinations where that code may run eventually. And container images solve some of that. But when you're using a Docker file to define how your container image is made, that still is an imperative process. It still isn't completely consistent. That still can have a variation between teams for how your build strategy is being defined. So basically, what that's a problem because in order to be able to implement consistency at scale, we need to start with consistency with this very base building block of container images.
Exactly.
Is that
Yeah,
okay? So the
100%.
problem is how to make what totally consistent container images is the problem statement.
There's two problems that we want to solve with the Tanzu build or with build
Okay.
engines. One is
Okay.
consistency, because consistency will help you, like on the operational aspect, consistency will help you understand exactly how you build all of your application components across the organization. Another thing we haven't mentioned is that because of that cloud native and microservices architecture, the number of workloads you will have is exponentially growing every time.
Yeah.
So
Yeah.
if we in the past, if we had 1,000 servers or 2,000 or 10,000 servers, now we have millions. So if you
Uh-huh.
want to, like, when you need to manage and operate that kind of scale of workloads, if you're not
Uh-huh.
consistent, it's going to be pretty much impossible. Um, and that leads me into the second problem, which is security.
Yeah. Uh-huh.
So how do you secure all of those workloads, right? When you if you're not doing that, if you're not shifting left security and creating like something which is secured by design,
Uh-huh.
and has less vulnerabilities and attack surface before even getting into production, it's going to be pretty much impossible to secure all your workload based on container images across the organization. When you use
So,
Dockerfile, that just
uh-huh.
one more thing. When you use Dockerfile, you do that manually. So
Uh-huh.
if a dependency, like if you find a new vulnerability for a dependency, you now need to go and change that on your Docker files or in the way that you're creating the container images. What we want to achieve is something which is not human driven, but an engine that does that for us. It's something like a automatic process that would automatically create new revisions based on changes of code or changes of dependencies or new vulnerabilities that we found. So that's the main essence of TanzuBuild.
So what I would like to do next is to have a succinct definition of what Tanzu build is, and then we'll get into how it works. Does that sound good?
Yeah. So
Okay. Well, yes.
yeah. So
Tanzu build.
TanzuBuild is a build engine that allows customer to push code or commit code into a repository and get an opinionated container image that has less vulnerability and consistency across the different layers of that image. Now, again, the most important thing is an engine,
Uh-huh.
right? It's running, it's a process that runs automatically regardless of something that I need to do manually.
So Tanzu build is a build engine that allows you to input code and receive a
Container
uh-huh.
image, a secured, curated container image. Now, I don't want it to sound like you get a container image without any vulnerabilities and it's going to be like clean and everything. That's not something
Uh-huh.
you can do. Like there's no such thing as container image without vulnerabilities. But you will definitely get less vulnerabilities than if you're building that with other layers, and you will always gonna have new revisions of that container image based on changes in dependencies and new layers that comes into play. So again, what we're trying to achieve is consistency and security.
Uh-huh.
Once you do that automatically based on any change, you will get that consistency and security. You will still
Okay.
need to scan that and you will still need to manage the images, but you will get that out of the box. It's
So
the Tanzu build is part of, like, it's based on the cloud native build packs engine. So it's an open source project. You can use that outside of the Tanzu solution or portfolio as an open source as well.
awesome. So I want to get more into build packs and how they work, but I think the next thing to talk about is like maybe from a linear point of view how this all works instead of jumping straight to build packs. I kind
Yeah,
of want to know.
yeah,
I want a linear path. So
okay,
let's say we have a developer. This is going to be like I'm the back of a laptop, we'll pretend. But this is application code.
Yep.
Actually, I'm already making an assumption. When I say the back of a laptop, it might not be. It could be, is the application code in like a Git repo or is it local?
So yeah, first of all, most of the time, and that's the best practice, in most times you will find that in a Git repo for source control. But Tanzu build can run either on a cluster side build or in a local build. So if a developer develops code on his own computer and he didn't check out like to a Git repo or didn't commit to a Git repo, and he still wants to build locally on his own Mac or PC, just to make sure that it works and everything is fine, you can use Tanzu build to do that locally as well. And I think that's one of the key things is that you need to decide if you're building that local build or cluster side build. I think that for our discussion, I think it's better to talk about cluster side build because that's the enterprise way. But just as a comment, you can also build locally.
Okay, so cluster side. And then I made myself the developer. So if you don't mind saying she from now on when you talk about the developer, thank you.
No problem.
I'm kidding. Cluster side or local. Okay. So I'm the developer. I have some app code. I want to deploy it eventually. And so next thing that needs to happen is building. So what do I do?
Right. So first of all, let's talk about like the process because it's also
Okay.
important. We've talked about the layers. Let's talk about the process of the build. What happens? So the first thing is Tanzu build will analyze the code. Which language are you using, right? Because based on that language, there's going to be different way to compile that code into a binary to run. And then based on that application code language and the binary, Tanzu build will decide what is the best application runtime and application dependencies to attach to that binary to run it. And of course, also the OS and or infrastructure services you will need to run that specific application. So before you're writing anything, I went over like the process, right? So now let's see how it actually goes. Because we will focus on cluster side build, let's talk about the process itself. And in the process, you will probably gonna have as an organization, you will probably gonna have supply chains. Something that is external to the process that has the pipeline management and the path to production management from code into production. In most organizations, that can be either GitLab, GitHub, Jenkins, Tecton, Azure DevOps, right? There's a lot of different supply chains that you can use, but I think those are the main ones.
GitHub,
GitLab, Azure DevOps. And as part of our portfolio, we will have our out-of-the-box supply chains inside the Tanzu platform.
So I like this. I guess sometimes when there's like a solution that's all zipped up for you, I know it's including some opinions, and sometimes that makes me a little worried. So I already like already that it's like, okay, no matter where your supply chain is, no matter where you're coming from, it plugs into this Tanzu
Eventually,
build.
all of those supply chains, even the internal ones, so even out of the box supply chain, will run the same Tanzu build command to initiate that build process, right?
All right. That was going to be one of my questions. So it is a Tanzu build command.
Yes.
Okay.
Now, again, I'm just going to refer to the local side as well. If you're on a local machine, you will then get into the folder of the code and run Tanzu build from that folder, and that will initiate or trigger that build. Either if it's local, it's going to be on a Docker container that will be spinned up in your own machine. And if it's supply chain driven, it's going to be part of the runner of the supply chain. One of the runners in one of the supply chains will run that Tanzu build against that code and read.
Okay. So maybe I'm typing it with my fingers. Maybe I'm just sending it to my normal supply chain and the supply chain is running it as part of
Exactly.
its process.
Now, if it's a supply chain and you
Uh-huh.
pointed out your repo, not in a local way, that
Uh-huh.
supply chain will probably gonna be triggered by commit, by a change. So if you change something and you commit that change, that supply chain will be triggered, and then another build process will be initiated. We've talked about
So
like, yeah,
it also works with GitOps. So this,
yes. So,
so yeah.
but again, GitOps is more like for the infrastructure side of things. When you build
Mm-hmm.
your code to a container image, that's
Mm-hmm.
the build process or the build side. It's not even we didn't even got into like the deployment or the way that you're deploying that image. So it is like driven by the supply chains in a way that we wait for a trigger of the commit happened, now the supply chain will run, and it will run Tanzu build on the new code, and then it will create a new container image. Now, the code was just one piece of the Tanzu build, right? Like,
Mm-hmm.
as we've said, it's not just the code or the application, there's other parts for that container image, which is the base image or the base OS, and then the
Okay.
dependencies and all the layers that you need to run them. Two
Okay.
sides of
So
the build, right?
there
One
are
for the
two sides.
application, one for the infrastructure.
Okay. So application code is one input. And then you said a base OS is another input.
So there's two parts of that build. One is
Uh-huh.
to compile the code, right? To create
Uh-huh.
a binary from the code, which
Uh-huh.
is how do I take that code and compile that into an application? And then
Yeah.
once I have that, what are the other layers that I need, like OS, application runtime, and so on and so forth, to run
Uh-huh.
that binary? So the
Yeah.
base OS or the part of the Tanzu build that is responsible for everything which is not the binary of the code, that's the
Uh-huh.
base OS. And that will contribute the layers to run the
Uh-huh.
application itself.
Okay.
That's the base OS. The second thing is the build pack. The build pack
Okay.
is what actually takes the code, analyze the code, and then compile the code based on the language.
Oh,
If,
so when we talked about cloud native build packs before,
yes.
that's okay.
And if you want to know like what languages are supported, easy to find. Just write cloud native build packs and you will get that. But Java, .NET Core, and there's a lot of languages that are supported. The most common one are supported as part of the cloud native build packs.
So you said it detects language,
And
it
compile.
detects dependencies here.
As part of that, it will add the dependencies based on the language that it needs. Like, let's say
Okay.
Java, it will take a look on the dependencies that is part of that code, and it will pull the dependencies, of course. Yeah.
So
So
okay, detects.
it's basically an opinionated way to build your code,
Uh-huh.
and then I think more importantly is there's an opinionated way to create all the layers underneath that code to run it, which is the base OS. Because you will
Okay.
find a lot of vulnerabilities, not just in the dependencies, but also in the layers that you attach to it. An older version
Mm-hmm.
of the OS, TLS that is not in the right version, a lot of different layers that has different vulnerabilities around them, like logs and others. So it's a combination between a type of opinions on the base OS and a type of opinions on the way that you build. Now, the next question that you should ask
Well,
is
you don't even need me.
with all the opinions, if I want to do something else, can I? Right? There's a
Yeah, that
question.
was. Give me a chance. That was going to be my question. So exactly. So like I assume, or is it a correct assumption to say like Tanzu platform comes with opinions out of the box? That's my first question. Yes. And then what if I don't want to use those opinions? What if I want to add my own specific
so
opinions?
so first of all, I think that that's my personal opinion, right? But opinions are important. Like opinions are not a
Yes.
bad thing. Because when you have
Okay.
opinions and you have opinions that are like strict according to best practices and strict according
Yeah.
like on security lines and everything else, that's actually good because it will improve the way that you do things. From the other
Uh-huh.
end, of course, if customers wants to build their own builders, they can do that.
Uh-huh.
Like they can change anything they want inside that mechanism to build with their own, let's say, golden image. If they have a way to do things like special versions that they're using or dependencies, so on and so forth, they can definitely do so.
So you're saying the word builder. Maybe this whole space here is a builder?
So that whole thing, like the entire
Uh-huh.
queue, that's a
Uh,
build plan.
a build
That's
plan.
in a build in the Tanzu builds. There's a concept we call Tanzu build plan, which is
Mm-hmm.
basically that is the recipe for how do you want to build. What is the build pack that you will use? What is the registry that you will push to? What
Mm-hmm.
are the configurations that we should add as part of the build or as part of the post build after the build into the container image? So that's a build plan.
Repeat some of those things again. A registry.
Yeah, the registry, the code, the build pack,
Okay.
configurations of the output files. We will get to that in a couple of like minutes. But best practices that we think we should add into the container image. Now let's double click on that for a second.
Okay.
So we've talked about like building the container image, right? That's part of the build. When you do Docker
Uh-huh.
Compose, you create a container image. But then what happened next? When you have that container image and now you want to deploy it, now if in most cases, of course, we will talk about Kubernetes, how do you make sure that container image will be deployed into Kubernetes with the best practices of like the policies of the organization or best practices that we know of? So
Yeah.
what Tanzu Build does, it's not just building. I know it's Tanzu
Mm-hmm.
Build, but it does plus. And the plus is
Mm-hmm.
basically creating the output files or the manifests to take that container image and then push that into Kubernetes. So when I've mentioned best practices, just an example is that if it's a Java code, and we know Java better than anyone else, we know that when
Mm-hmm.
you build a container image for Java and you want to deploy that into Kubernetes, there's a couple of things we think we should add, like health checks, graceful shutdowns, and other things, right? A lot different configurations that we know you should have as part of the deployment of that Spring application.
Mm-hmm.
We are doing that automatically as part of the build. So when you get the output of that build, you
Mm-hmm.
basically get a container image, but you also get all the configuration files to deploy that image afterwards into Kubernetes.
So I like to think of things in terms of inputs and outputs and what's running. That helps me understand.
Yeah,
So I understand we have application code as an input.
yeah.
I understand the cloud native build packs is running with my application code to help build it into a container image. Is the base OS of my application code? That has all
The
those
base
supporting layers?
the base OS is related into the build pack, but basically the base OS will
Okay.
add the layers underneath that code to run that.
Okay.
So based on the build pack you will choose, the base
Mm-hmm.
OS will be part of that. The
Okay.
reason I've divided between the two is because those are two different like layers or two different aspects of what you need inside a
Yeah.
container image. But when you create in the build plan, when you point out into a build pack, that will also
Uh-huh.
decide on the base OS.
Okay. So the application code plus the base OS go into the cloud native build packs that detect the language add dependency. And then that goes into the build plan that also adds registry, configuration, best practices.
Yeah.
Yeah. Okay.
You can also represent on the right side
Uh-huh.
like a manifest of configuration, because we have not in the other side. Sorry, you're right.
Okay.
So because what I mean is, we've talked about best practices and configuration. That build
Uh-huh.
plan has a file of configuration that we actually apply either locally or on the cluster side to have all of those configurations up to date. And if something is changed, or if you as the platform engineer wants to change anything, you can change the build plan, and that will change the entire way that you build things. So that's another input. So and that's the build plan configuration file.
Oh. Okay. So build plan configuration file.
Yeah. And that's where you actually states what's the output. If the output is going to be just a Docker file, like a Docker that you can run, or it's going to be a Kubernetes manifest, or it's going to be a package like Carvel package, right?
Mm-hmm.
That build plan configuration will have all the recipe of everything. Like what's the registry, what's the code, what's the build packs. Yeah. And it's basically the
Okay.
same as build plan, but that's the actual configuration file that will run.
Mm-hmm. Okay. So can be default or can be custom, yeah?
Yes. Now, I think one of the things you've mentioned is that you want to know, like, what's the engine, what's actually running.
Yeah. Yeah, that's I
Because
do really want that.
yeah, because we've talked about like parameters, right? We've talked about the different configurations. What
Uh-huh.
actually runs is when you trigger that Tanzu build on a
Uh-huh.
local machine, that will
Uh-huh.
trigger a Docker container that will
Okay.
create the different steps to build that image. And we can see that, we
Okay.
will see that in the demo. The different steps that basically we go through to create that container image, which is analyze, add layers, export, and so on and so forth. What you can
Can I
all, yeah,
can I draw that container on here?
well, it's basically you can, yeah, you can maybe do like
Or
like a machinery wheel or something that says that's gonna run and build your machine.
okay. So let me just so I run the Tanzu build command. I'm sorry if I'm being redundant. And
That's
so
okay.
my inputs are input 1. My inputs are an application code.
And that's
Input
it.
2,
If you're the
yes, for
developer,
me as the yes.
exactly.
Uh-huh.
For you,
Nice.
that's it.
Uh-huh.
For the
And
platform
then
engineer,
uh-huh. And then
there's
the platform engineer has defaults or can make choices in the base OS, which is like what's running underneath the application code.
yeah,
So that's input 2. And then input 3 is the build plan configuration file. That's what.
the cloud native build packs.
Okay. So and then so
It's actually both the same, so you can do 2.5.
oh, okay.
So the
I'll
base
just put a
OS
little
and the
circle.
cloud native build packs, that's part of
Okay.
that's input for basically how to build.
Plus.
Yes,
Okay.
exactly.
So input 2, and we're calling that how to build. I like this.
Right. How to build.
How to build.
And then input 3 will be the registry on your build plan. That's input
Okay.
3.
And that's the configuration file. We're
Yes.
all build coming together for this build plan.
Yes.
So this is input 3.
And that's gonna have the registry to push to, right?
Okay.
Because we haven't represented the registry yet.
So it has registry, and then any other configuration we want to mention here?
Yes, it's gonna have the registry and the output format. So how do we? What's the output files? Will it be Kubernetes, Docker, or Carvel?
Okay.
And that's the output 3. And then
Okay.
everything is basically part of the build plan, right? Like everything is part of that build plan that will be configured locally or on the cluster level.
Okay, so all of this is going toward the build plan. The input, the application code, all right, app code. The configuration
The configuration and the build packs.
and how to build.
How
Yeah,
to
the
build.
build packs. And
Once you
in
have
the
that configuration file, now the developer can run Tanzu build, and everything will happen for him in the backend or in the back.
okay, or her or Whitney.
Sorry, it's Whitney. I will stick to Whitney. So you can definitely get everything done behind the scenes without knowing what's going on, right? Now let's
Yeah.
talk about what's the output, because from that cube, now we get a container image, right? Like the output of that will be a container image that we are pushing into the registry that we've,
So now
yeah,
the output is a container image.
we've configured the registry, right, as part of the configuration. And the first thing is we will get that container image pushed into the registry with the tag that we've decided. So as part of our project, because you can have different teams. By the way, you can have different teams with different languages, right? The fact that I've mentioned Java doesn't mean anything. Like you can have one team that is developing on Java and another that develops on another language. They can both use Tanzu build. And once you're pushing into the registry, you will push to different projects based on the team that you're part of. So that's going to be, yeah.
So does that make for I think that's cool, but it makes me wonder, like, is it wasteful? Does it mean it's like a really long build if it doesn't, like,
No.
is there extra compute cost in being able to build from any language?
So it's not, no. And
Okay.
the difference is in the configuration of the build packs itself. It's not
Uh-huh.
an overhead.
Okay.
If it's long or short, it depends really on the type of language and the process itself. But
Uh-huh.
there's some, like, as part of that build, the build process will reuse layers and reuse configuration on the
Ah.
second build to make it
Okay.
fast. So on the first one, it can be like longer, and it's gonna be shorter later on the second and fourth. So
So
now we have
output is a
version one.
container image registry. So we have an image. We're gonna call it Whitney's app.
Yeah, and we have Whitney's app on version one.
V1. Okay.
Right. And the second thing as an output is we will have the configuration file to deploy Whitney's app on our Kubernetes cluster or on a different platform.
So is there like another artifact registry it pushes to with that configuration
It's
file?
creating an artifact based on the
Okay.
location that you build. Like it will create an artifact either locally or on the cluster side, but it will create the artifacts to deploy that container image. Now the artifacts will change based on the configuration from that build plan that we've talked about, because it can be, as I said, either Kubernetes or Carvel or something else.
Is calling it a deployment artifact? It's the image.
Yeah.
Correct.
It's the deployment.
Okay.
Yeah. When we will get into
package. Yeah.
it can be a package. It can be also just a manifest, just a YAML file with configuration for Kubernetes. So it really depends on what you configured. But when we will get into the deployment phase on our next chapter, we will talk about the package and what's in the package and how do we leverage packages for lifecycle management. Because one of the things that we want is to manage our packages just like we are managing our code. And that's exactly what you did. It's a package V1. So it's not just that we are source controlling the code or the image, we are now source controlling the runtime, the package itself that is pushed into the runtime.
Oh.
Right?
Okay.
Because the package is also an artifact that you can manage through GitOps, and that's where GitOps comes into play. We will talk about it. But then when you want to deploy, I don't have to build every time I need to deploy, right? I can build and then take the artifacts and just deploy the artifacts because the container image is already there. Now, there's a couple of reasons why I want to deploy without build or why I want to build without deploy. It's different, like between the different processes and environments. But either way, you will have all the options. We will talk about it in the deploy step.
Okay. So I'm going to talk about how I think it works, and then maybe that will relate to how it updates when we want to update. But let's review what we have so far.
Yeah.
I'm a developer. I have some application code. It could be a laptop. It could be on Git. Regardless, but I push it, and I have a Tanzu build command that I can run myself to run it all locally, or this can go through my my normal pipeline.
Yeah.
And then regardless, that's an input to this Tanzu build system.
Yeah.
Now, that's just me. Unbeknownst to me, Whitney, the developer, this is all already set up for me. I have this cloud native build pack story, like how to build, which has cloud native build packs themselves, which do the work of detecting the language, adding dependencies, doing all the things needed for a build. And then as part of defining how to build, we defined what base OS and system and if there's any modifications to that. And the opinion, Tanzu has opinions out of the box, but then if I, as a platform engineer, want to change those things, they're configurable. So unbeknownst to developer Whitney, there's a whole strategy for how to build that's behind the scenes. And also there's a strategy, some things defined about what registry I want to push to once that image is built, what I want the output format to be for the eventual artifact that has the configuration built in with it. And there can be other things defined here too.
Yeah.
So all of that comes together to make this build plan. Again, it can be Tanzu best practices or org-specific opinions, but it's going to include a registry address, the code, the build packs, the configuration for the deployment, and all that to say, Whitney, the developer, runs Tanzu build, all this stuff happens, and then a very consistent image with best practices gets pushed to the container registry that was defined, as well as a deployment artifact with deployment opinions and best practices.
Exactly.
Excellent. So what happens when I update code? Yeah, what do you want to say? I'm sorry.
No, that's okay. You've just mentioned like one of the things, like you answered one of the challenges. You said consistency, right? We got consistency. We have a way that we are building code in a consistent way, without changes, without snowflakes, without creating like a mess we can't actually operate and manage. The second thing we've talked about is security. And security also comes into play by opinions, because we will have the least amount of vulnerabilities in the dependencies and layers that we will add. The question is, what happens with something changed? Like if something is changed in the dependencies or in the code or in the base OS, right? Things can change. So let's talk about a change. The first thing is we've talked about Tanzu build command that basically triggered by a supply chain. So if you as a developer, if you, Whitney, push the change into the repo, the supply chain will pick up that commit, that change, and trigger a new Tanzu build with the new code, right? That will initiate the entire process again, and you will get Whitney's app version 2. Yes. The next question is, what happens if something is changed not by you, Whitney? Something is changed in the dependencies. We found our new log4j, right? We found our new vulnerability that we must now change everything for because of it. And here we have the same routine of a change, because those supply chains, or the internal supply chain, at least at first from Tanzu, will also listen for a change in the build pack. And if in the build pack we've decided that there's a layer that we need to change, we will change the build pack, and that will trigger a new build, pushing it to the registry as Whitney's app version 3.
Oh.
And that trigger wasn't because of the code. That trigger was because of the build pack changed because of a vulnerability or a dependency that changed or something.
So that back to the security issue.
Version 3.
If oh yeah, thank you. If just checking to see if you're paying attention, right?
I am.
No, I'm kidding. I was already asking my question. Or so if another log4j happened, instead of having to hunt down every time it's used and manually change, now because of consistency and because of security, it can all automatically be rebuilt without even bothering our developers.
Exactly. Well, you will bother the
And
developer
then,
because if you
uh-huh.
change a dependency in the code, you probably need them to either make the change or test the change and like there's a lot of things that you will probably need. But the most important thing is that if you have that consistency, if you have that
Uh-huh.
golden path to production, you don't need to change 1,000 pipelines or 1,000
Yeah.
ways of building containers. You can use your consistent way, changing it once, and get new revisions for your old application that needs to have new revisions. Again, that doesn't mean that it will auto deploy. That it will
Uh-huh.
create a new build and push that into the registry. Now you need to decide how do you want to deploy, when do you want to deploy, and roll that update into your environment. But yeah,
So, what you're telling me, what I understand, there's something you mentioned in passing before that I didn't write down, but I'm remembering it now, and that is that layers don't need to be rebuilt if they've already been made. So, are you telling me if a new vulnerability comes up, a new log4j, does that mean that the application image, like application layers of the image, don't need to be rebuilt? Like it's a faster build to fix it?
so if the layers that has the vulnerabilities
Uh huh.
changed, the build will pick up that change and not it's not going to use the same layers, it's going to replace them with the new layers. Exactly like that,
Oh.
if you're using a new dependency and you change the version of the dependency, that will
Uh huh.
compile the code again with that new dependency without like the old one, right? And so that the phase of like reusing layers is
Uh huh.
if nothing changed. Something
Okay.
is changed, it will create a new build.
That's great. That's like a faster build, but it's also if it's not rebuilding something, it's just less likely anything's going to go wrong upon
Yeah.
rebuild too. So again, with consistency being
Again.
key.
Yeah.
All right.
Yeah.
Is there anything else you'd like to say about Tanzu build?
No, I think we went through all the mechanics and the process and the different components and configurations. I think it's going to
Uh
be
huh.
great to watch it live and see how it goes.
Yeah. Let's get behind the computer and you can actually show this in action. I can't wait to see it. Hello, we're back and behind the computer now for my good friend Oren to show all of us how Tanzu build works actually from the machine. So I'm going to share your screen, Oren,
Yeah,
and
cool.
take it away, friend.
Thank you. Okay, so we've talked about like how Tanzu Build does it magic, and now I'm the developer.
Mhm.
And we also
Okay,
said that as the developer, I don't need to think about anything except committing a change of the code, and then the supply chain, either any supply chain that we've talked about, GitLab, GitHub, Azure DevOps, or something else, will pick up that commit.
Jenkins, Tecton, yep.
Exactly. Those will pick up that change and basically trigger the build. But because I want to
Mm-hmm.
show you the behind the scenes and inside everything, I'm just using my own Mac. So I'm not in an organization right now. And the first thing I will do is I will clone my Git repo, right? So I will
Okay,
take my Spring Metal application and I will put it on a demo folder demo. Right. And now I'm basically cloning my code
uh-huh,
and I'm opening my editor code. Now I have everything that I've already coded in my repo. I don't need to change anything. I just want to build that application and then run and see how it goes, right?
yep, uh-huh,
There's a couple of things that have to happen before I can do that, even if I'm running it
okay,
on my local machine. Now, again, in an organization, that this will probably going to be something that the platform engineer pre-created, and that's one of the things that we have to to take in consideration is all the configuration of the platform configuration. So we've talked about a lot of different things, on the platform configuration. One of those
Mm-hmm.
was, where should I put my package, right? Where should I aim my container image?
Uh-huh.
What's my registry? So in
Yeah.
this file where you can see the container app build plan, you can basically see all the different things that should be pre-configured. The registry with the project. So in this case, I'm pointing to my Harbo and to a project that is basically the Tanzu application platform applications. I'm choosing my builder. Now, when you choose your builder, you can either choose something that we are providing as part of the Tanzu build, or something you've built inside your organization to align with your policies and best practices. In this case,
Beautiful.
I'm just using the base one. And then you can see post build steps. The post build steps, we've talked about it. I'm not just building the code, building the container image, I'm also creating a manifest. And in that manifest,
Mm-hmm.
I want to add and inject best practices that I know should be there as Tanzu, and the customer will
Mm-hmm.
just benefit from those. So, what we are adding to a post build step is applying Spring Boot conventions. And that will automatically add to the different manifests, the different YAML files, all the configuration that is a best practice to run Spring in your environment, and we will see that.
Nice.
Another thing which is super important is that we've discussed about how to create those different manifests and to where do we want to deploy them. Now, in this case, what you're seeing on the runtime is you can see a Kubernetes Carvel package, which means that
Mm-hmm.
this specific configuration will create a runtime based on Carvel package, and you will see that when I will create the build. But we also said that we can do that for other runtimes. So if I'm showing you the other
Yeah.
configuration, which is not part of my configuration right now, I can also configure a Kubernetes plain one, and that will just create a bunch of manifest of Kubernetes that I can then deploy. Or I can just create a container image, and that will create a Docker file that I can then run. So
Okay.
those are the pre-configurations that we need to do on a machine before starting, like before running that Tanzu build.
So as a developer, well, maybe a platform engineer is going to set it up, but at this point, you need to think about where do you want that code to land? Like, where is it going to end up? And so, for the final part of our build stage, how exactly we're going to, how is it going to be packaged? And it's likely
Yes,
a developer won't think about that part, that a platform engineer person will set it up for them. Got
exactly.
it. Cool.
Now, the second thing you need to do as a developer is a command called Tanzu app init. The Tanzu app
Mm-hmm.
init command will create the base configuration that you need to then build your application. So what's the application name? Would you like to replace the current files because I've already created ones? Let's do yes.
Mm-hmm.
That's the source of the application, the path that I'm in, of course, and which build packs I want to use, and that's it. Now, that command will create the file that basically points out to the rest of the configuration. So you can see a Tanzu YAML file that points to
Nice.
.tanzu/config. Then if I'm going
Mm-hmm.
to the config file, you can see basically a basic configuration for my application. What's the name? What's the build packs that I'm using? What's the path that I'm building from? What's the port that it will be exposed in, which is 8080. Up until now, easy peasy, right? So now
Uh-huh.
it's even
I
easier.
I like that the interface is in the IDE too. I like that. Yeah,
That's
it's
the
right where the
developer
code is, right
experience,
where I want to
right?
be. Mm-hmm.
I'm a developer. That's where I live. I don't live in other places, so that's why everything is inside that IDE. So now I'm
Yeah.
doing now the only command I need to run is the Tanzu build. I don't need to configure
Mm-hmm.
anything else. Everything was pre-configured for me. As the developer, I just need to do the Tanzu build. Now I want to show you the output, so I'm gonna output the build or the build artifacts into the build output folder. Now,
Okay.
what are the build artifacts?
The
You
build
remember?
artifacts, yeah,
Yeah.
it's what's coming from the builder. So for me, I wanted it to be a container image, but it really can be more than that. Container image, it also was going to have the address of the registry you want to push it to, and then also where
So all the
stuff about the final
configuration,
manifest you want to make. Mm-hmm.
right? It's
Yeah.
gonna be all the configuration plus it's gonna have all the artifacts to then deploy. because we've said we
Mm-hmm.
wanted a carvel package, so all the files of the carvel package will be there. Now, regardless
Mm-hmm.
of that, as part of the build, we are creating an SBOM, a software bill of material for that package, and that will also be part of the build output. So we are
Oh,
basically, the build output is everything from configuration plus manifest for deployment. And obviously, I'm gonna push my image into my registry with new revision because I'm creating a new
uh-huh.
build, right? And again, I'm using
Yep.
Arbo, so I can show you the Arbo afterwards.
Beautiful.
So I've just run that command. You can see it's picking up that YAML file of configuration. It's checking that it can configure and connect into my Arbo. So it's just checking that it can actually interact with it. Now it's
Mm-hmm.
analyzing the code. So it's, we've talked about it, right? The first thing is to know which code is it, and then based on that code, decide what to do. So it
Mm-hmm.
knows that it's Spring. Let me go up. It knows it's Spring, and now because it's not the first time I'm building that code, it's
Mm-hmm.
not just identifying what it needs, which is all these build packs. It needs CA certificates, Belasoft libraries, SIFT, Maven, executable jar, and so on and so forth. It's also restoring all the layers that I'm already using, right, for that specific
Uh,
image. It's just gonna make it faster. And then you can
yeah.
see it's building. Now, the building phase, that's the compilation, that's compiling that Spring application, and you can see it's running up until here. So here, it's basically ended that build phase. It created the binary of the
Mm-hmm.
Spring, and now it's adding the layers into the container image. So now it's building underneath that Spring app, right? Everything that it needs to run.
Mm-hmm.
And that's where you can see the Java security properties, the JRE, the class path, and other web application types, and so on and so forth. You can also see
Mm-hmm.
that it created that BOM, like the SBOM file, that was
Uh-huh.
using SIFT as part of that. So now, once that is over, it's basically saving the image into the harbor. So it's pushing it into the harbor. That's the new image with the new version, so the new revision. And then what you can see is it successfully built that. So we have a new image based on that code and everything else, and pushed into our arbor. But then we have a post build configuration. So in the post build
I
configuration, yeah,
I have comments and questions. First, a comment, and one thing I'm noticing that I like a lot is that like you have your application code, and it's considering everything that goes under your application code, but then it's also considering dependencies and stuff that go on top. So I just like that mental image.
it's end to end.
And
That's exactly the point.
it yeah. And then another a question I have is if you're building it the image in this way now on your machine, if some other developer on another machine builds it, or if gets built in the cluster, is it going to have a different image in the
Yeah,
end? Will the layers be different? Yeah.
it's gonna be a different image.
Uh-huh.
It shouldn't have different layers, because the layers,
Mm-hmm.
again, they are consistent, they are
Mm-hmm.
opinionated. We want them to be exactly the same. The things that will be
Oh,
different will be the code itself, and of course the revision. It will create a new image revision, but the
okay.
underlay should be the same.
Okay. So if you had the exact same code, you were building from the same code, it would make the same image. No.
It will make the
It
same
make the same
underlay,
layers.
the same layers, not
Okay.
the same. It will be a new revision either way. So every
Oh,
time
got
you're
it.
running build, it will create
Uh-huh.
a new revision of a container image and push that into the registry. Even if
Got
you're
it.
building locally, cluster side, even if you're building simultaneously, it will create new revisions because it's a new build.
Okay.
The build service doesn't know what's the commit, doesn't know what you
Uh-huh.
change in the code or if it's similar to something that someone else changed, right? So it will always
Okay.
gonna create a new build. Um,
Okay. It's a
so
brand new build, but with the same layers, with consistent properties.
yeah,
Got
and
it.
as you saw, I never said what are the layers that I want, right? I
Uh-huh.
never said I want to use that kind of layer, or I need CA certificates, or I need TLS, or I need that OS. Or I haven't said anything. The only thing I've said is Tanzu build. That's it. And I've pointed to the right cloud native build packs, which basically then everything is already pre-configured and opinionated, right? Like
Nice.
that's exactly the point, abstracting that complexity of choosing everything.
Mm-hmm.
So you can see that in a post build step, we've just run the application Spring Boot conventions, and we've decided to add automatically a graceful shutdown and actuator props and all the different configuration that we think is part of the best practice to run Spring. And then you can see it's also created the Kubernetes deployment and compile that into a Caravelle package. So
Cool.
now inside that build output folder, first of all, in the build, I can see my SBOM.
Mm-hmm.
So let's take, there you go. That's the SBOM.
Mm-hmm.
Uh,
Wow, it's so long.
there you go. So now
Yeah.
it's a bit easier to read, even though it's still like not easy. So you see it's Cyclone
Uh-huh.
DX and you see the SBOM, you see all the layers.
Uh-huh.
So we can go each
That,
layer and see, but it doesn't really matter. But what
that
we do with that, with those layers, is we
uh-huh.
also scan them for vulnerabilities as part of the Tanzu platform. So
Uh-huh.
when you create that build as part of the Tanzu platform, we also scan for vulnerabilities and show you in that build how many vulnerabilities do you have. Are the vulnerabilities in the dependency of the application or in the layers? Everything from top to bottom about vulnerabilities in that aspect. So from security perspective, that's a huge value proposition. And alongside of that, you can see in the output 4 different files. Container app, which
Mm-hmm.
basically describes the application. So that's the application manifest that will be deployed to eventually to Kubernetes, right? That's the
Okay.
YAML file with the image. And you can see there's liveness probes and readiness probes. Those are the things that we've added automatically as part of the conventions that we know you should have. You can see the git commit that is part of that, so you can then trace back from runtime, trace back into the code and the commit itself, which is super
Ah,
helpful. And
yeah.
everything is managed in a source control, as you can see, including the package itself. Now, to add to that, we are adding the Caravelle components and the Caravelle configurations. We are not going to get into the Caravelle configurations here, but I'm sure you had a brilliant episode on Caravelle that you can refer to, right? I'm not
Yes,
wrong.
yes.
You see?
He's talking about Enlightening, a show I do with my life board called Enlightening. Yep. Mm-hmm.
Exactly. And I think we can refer to that episode as well. But we honestly we will focus that on that aspect in the Tanzu deploy. But that's it. So I have my build. I've from that code just created a Tanzu build with an output of the folder. The Tanzu build took the code, analyzed it, understand what it is, added the layers, created the image, added the Spring Boot conventions into the manifest of the deployment, created the Caravelle package, and now I'm ready to run. Right, I'm ready to run either locally on my Docker or on Kubernetes or in the organization. That's it.
That's a great developer experience. And I think from here it's just one command to deploy it. So you don't actually even have to look through it and dig through it and see, like you just run another one and
So
it's got,
that's
I do have a, yeah.
that's a good intro for the next one because you don't
Uh-huh.
even need to do 2 commands. As a developer, once I'm in my code, I
Uh-huh.
can do
Uh-huh.
Tanzu deploy.
Uh-huh.
And Tanzu deploy will start with the build, but the next step will automatically be the
Oh.
deploy. So it's one
Ah.
command that builds and deploys. That's it.
That's it.
Yeah, easy, easy
I
peasy.
have one question.
Yeah,
I know we talked about how Tanzu's built some opinions in there, but can you tell me like an example of what's something where my organization can use put its own opinion into what Tanzu has defaulted?
you can build your own builder. You can decide everything,
Okay.
everything.
Mm-hmm.
Like if you have a specific
Ah,
image that you want to depend on, if you have layers that you want to add, if you want to change any configuration, you can build your own builder. That's the
okay.
best way to describe it, right? Because
Uh-huh.
I'm in my configuration file, and I will show you that again. Where is it? In my configuration file, I'm pointing out to this builder, right?
Uh-huh.
which is the Paquito build packs, build a jammy base. As an organization, I can build my own image, I can build my own layers, I can build my own builder, and then point to that, and that's it.
And still have this completely automated process and also make those opinions invisible to your developers.
And make your own opinions, right? That's exactly the point.
Cool.
Yeah.
Awesome.
Cool.
Well, this has been a pleasure. Thank you so much for teaching about Tanzu Build today.
Thank you, Whitney. It's always a pleasure.
Bye.
Bye.